Trinity, this is a really, really weird question, but I'm going to ask it anyways. In example A here, I got x times 2x plus 1 plus 7 times 2x plus 1. The weird question. How many terms do I have? 2. Yeah, I do have 2 terms, right? How are terms separated? By addition and subtraction. So in other words, if I said 5x, 5x is one term, right? That have 2 things that are being multiplied, right? If I say 5x plus 15, I now have said what? 2 terms, right? If I said 5x squared y cubed plus 5, 2 terms, right? So this is 2 terms. If you look at these 2 terms, do they share anything in common? 2x plus 1. So what I'm going to do is I'm going to factor a 2x plus 1 out of both. All right. Kind of like a GCF, right? Not kind of, it is. It's a greatest common factor. Now, this is where I'm going to ask a question that's going to be a little weird, okay? John, if I take 2x plus 1 out of this, what's left? X. Plus, if I take 2x plus 1 out of this, what's left? X plus 7. Okay? Just bear with the process for a minute. You'll see why we're doing it in like 5 minutes, okay? Here I have 5x times x minus 2 minus 4 times x minus 2. Do they share anything in common? And x minus 2. So I'm going to write those down. So if I took an x minus 2 out of 5x times x minus 2, what's left? 5x. And if I took an x minus 2 out of this, what's left? Negative 4. Okay? What do these both share? An x minus 7. All right, so I have an x minus 7. When I take an x minus 7 out of this, what's left? X plus 5. Plus, when I take an x minus 7 out of this, what's left? X plus 1. Now, in this case, guys, I can actually take some of these things and what? Combine them, right? That gives me 2x plus 6. Anything here that they share in common? The x plus 4. Okay, and so when I take x plus 4 out of this, what's left? 2x plus 8. This piece is a little confusing. When I take x plus 4 out of this, what's left? Negative x minus 2. So I'm subtracting that whole thing, right? So that means I'm going to distribute that minus sign. Is that cool, Blake? You like that? Good. I'm going to leave it right there. We'll just leave it right there. All right, so what this example 23 is asking us to do is it's saying, okay, well, I want to know whether or not this process that I just showed you guys works, right? I want to know if it works. So here's what I'm going to do. I'm going to take this value of 2. I'm going to plug it into this and see what I get. Then I'm going to do that process that I just showed you guys and see if we get the same thing when we plug into. Okay? So I'm going to test using x equals 2. So if I plug 2 into this, what would I have? Well, I would have 2 plus 3 times 2 minus 4 plus 5 times 2 plus 3. I just plugged in, right? So what does that give me? That gives me a 5. That gives me a -2 plus 5 times 5. Order of operations, right? Trying to follow the order of operations. This gives me -10 plus 25, which is 15. So I should get 15 when I do this, right? All right, now let's do that process that I just showed you guys to see if it works. How many terms? 2. They share anything in common? The x plus 3, right? All right, so I have the x plus 3. All right, what's the stuff that's left over when I take the x plus 3 out? X minus 4 plus 5. It's the stuff that I didn't highlight, right, guys? I mean, are we getting the idea with that, right? It's the stuff that I didn't highlight. That's the leftover stuff when I get rid of those common terms. And what is x minus 4 plus 5 the same as? X plus 1, right? All right, so I think that this is the same as this. Well, let's test that x equals 2 to see what happens. If we did everything right, we should get what number? We should get 15, right? Well, that gives me 5 times 3, which is 15, right? So it seems as if the process makes sense. It seems as if we're doing something that works, right? And that's just taking a GCF out. All right, so what I'm going to show you guys here is a method. Is that okay? Did you guys get that? Am I going too fast? All right. So check this out, guys. All right. Here's what I'm doing. Here I have something that has 3 terms in it, right? Oh, I'm sorry, not 3, but look carefully, Hezzy. I got 1, 2, 3. I got 4 terms, right? Now, what I did was this: is I just threw some parentheses in here. Notice that I have additions and subtractions, right? Do you guys agree that associative property lets me put some parentheses in here, right? Then look at what I did to go from here to here. This is really important, guys. There's a 2x squared that's outside of parentheses. If I asked you guys to find a GCF of just these 2 things, what would it be? 2x squared, right? Leaving x minus 3, right? If I asked you guys to find a GCF of just these 2 things, what would it be? 5, leaving x minus 3. So do you guys agree that this is nothing more than a associative property, right? Which is parentheses, right? So this is something with an associative property. Guys, do you agree that when I factor out a GCF, isn't that like reverse distributing? Yeah, this is like a distribution, right? And then here, guys, I moved parentheses around again. So this is another associative. All right, so why am I showing you this, guys? Right? Why am I all of a sudden like finding GCFs of 4 things, right? It's really, really, really gonna be a simple process. When you have 4 terms, T, when you have 4 terms, you're gonna think about this method. And this method is called factoring by grouping. You're only going to use this when you see 4 terms and the word factor, right? If you see 4 terms in the word factor, you're going to think grouping, okay? And the way you're going to do this is very, very, very simple if you follow the directions. Step number 1. Create your two groups. Now, what do you notice about the sign between the two groups? All right, it's negative. So I'm always going to put a negative sign there. Okay, find the GCF of the first two groups, of the first group, this group here. Find the GCF, x squared. Yep. And when I take x squared out of 3x cubed, what do I get? 3x. And when I take x squared out of 2x squared, what do I get? 2. All right, minus. What's the GCF here? Well, it can't be 27 because 18 is smaller, but 18 doesn't go into 27. What's the next, hang on. What's the next biggest factor of 27? 9. Oh, I'm sorry, I said the wrong thing. What's the next biggest factor of 18? 9. Does 9 go into 27? Yes. So 9 is the GCF. Now watch, guys. When I write that 9 down, did I really write down 9? I really wrote down -9, right? Because that sign I told you guys to what? Keep there, right? Does -9 go into -27x? Yeah, how many times? 3x times. Does -9 go into -18? Positive twice. And look at what I just did. Didn't I just create something like we did on the first page? Do those two sets of things share anything in common? They share a what? They share a 3x plus 2. So we're going to take that out. And what's the stuff that didn't get highlighted? X squared minus 9. And that is factored. Now, guys, I'm actually lying to you a little bit because there is one other thing I could have done. Yeah, the x squared minus 9 was a what? Was a difference of perfect squares, right? So wasn't there like another step I could have taken, right? Now this is not a part of the grouping method, right? We've done it, right? This is done. This is grouped. Right, the grouping, oh wow, that's just, you can't even read that. The grouping method is done. Right, but I noticed that I have a DPS there, right? So that we can factor again, right? So I would have 3x plus 2, and then I would have an x plus 3, and an x minus 3. Will that always happen, do you think? No, right? It's just, this just happens to be a case where it does happen. I'm going to come back to B in a minute. All right, let's go to C. Again, two groups. What sign is between the two groups? A plus sign. What can I take out of x to the 5th and 4x cubed? An x cubed, right? When I take an x cubed out of x to the 5th, what do I get? And what's 4x cubed divided by x cubed? 4. Right, so what's that process right there? I grouped and then I took a GCF of each of the groups and factored it out, right? Okay, 2x squared plus 8, what do they both have in common? All right, so I'm going to take a 2, and I'm going to factor out the 2, right? And does 2 go into 2x squared? Yep, x squared times. And does 2 go into 8? Yep, 4 times. Did something match? So that's one of my factors. What's my other factor? X cubed plus 2. It's the stuff that I didn't highlight, the stuff that I didn't use, the stuff that wasn't common. Nothing else I can do on those, right? Is x squared plus 4 a DPS? No, because it's what? Plus 4, right? If it was minus 4, it would be, right? Okay, D. Again, keeping that sign, right? You guys, it looks like you guys want to try this one on your own, so go ahead. Okay, what do you guys think? First pair, what do you guys want to take out? 5x? 5x squared. Why squared? Because that's the lowest exponent of a variable that they both have, right? All right, so I'm going to take a 5x squared. All right, and when I take out the 5x squared, what am I left with? X plus 2. All right, and what do you guys want to take out of this? 20, right? And when I take out a 20, what am I left with? X plus 2. Oh, wait, stop. Hold the phones. Actually, let's finish. We'll finish it. What do they both have in common? X plus 2. What's all the stuff that's left over? 5x squared plus 20. All right, so this was my common term. And the leftovers was the 5x squared plus 20, right? Now, I used the method, right? And I used the method correctly, and I'm assuming a lot of you guys might have done that as well. 3 questions. Question number 1. What happens if these two things aren't the same? Can I just highlight them and move on? No, it means one of 2 things. It means either I didn't get the correct GCF, or I didn't divide it out correctly, or it means that the problem wasn't factorable, right? If I didn't get the same thing, then the problem wasn't factorable, was it? Okay, so Blake, what I mean by that is this. What if I gave you this problem? Don't write this down. All right, and I said, okay, does that look like one of the ones we've been doing? What do you think? Looks like it, right? Group these two. Group these two. What can I take out of the first one? When I take out a 2x, what do I get? X plus 2. I always keep this sign in the middle. What can I take out of the next group? 3. When I take the 3 out of 3x, I get x. When I take the 3 out of the 9, I get 3. But what's the problem? What happened? Did anything match? No, right? Did I do anything wrong? No, that just means that this was not factorable. right? I can't use the method because it doesn't work, right? I don't have two common terms, okay? So is that possible? Sure it is, right? Sure it is. Okay, now why was I a little hesitant about this? Why was I hesitant? Yeah, thank you. Guys, right at the very, very beginning of the problem, what were the directions here? Use the method of factoring by grouping to completely factor the following. On this example, what should I have done before I did anything? I should have taken out a GCF. Didn't this have a what in it? What could I have taken out of all those? A 5. Absolutely. I could have taken a 5 out of all that before I even began the problem, right? How do I know that there's a 5? Does this term have a GCF in it? But does this one? Yeah. So that's why. So I should have taken out the GCF first, right? Should have taken out the GCF first. All right, so I mean, again, now I give you something like this, and I want to factor this by grouping, okay? Again, when you see how many terms? 4 terms. You're thinking factoring by grouping, right? All right, so I have, how can you rewrite this? All right, so what can we do here, guys? I'm going to take my x squared plus ab plus u. And I have that. Now notice something, guys. If I group it this way, look at the first 2 terms. What's the problem? There's no GCF here, is there? Right? There's no GCF here. So my question is this. I'm wondering, I don't know. Jameson, what do you think? I'm wondering if somehow I can reorder things so that it does give me a GCF. You want to try to reorder this so that maybe I can get a GCF? Oh, hang on a minute. You said x squared plus bx. This is a minus bx. I can't all of a sudden just change the sign of this. So keep the sign. I liked what you were saying, but keep the sign. X squared minus bx minus ax plus ab. You want to do that? Will that allow me to take a GCF out of this? Will that allow me to take a GCF out of this? It will, right? Now, Trinity's looking at me like, guys, all I did was what? I took this and this and this, and I just rearranged the order, right? I'm allowed to rearrange the order as long as I keep the signs the same, okay? So if I reordered it like this, I'm wondering if my method will work now. Is there anything I can take out of the first 2 terms? I can take an x, and when I take an x, what am I left with? X minus b, right? What can I take out of both of these 2 terms? An a, right? Well, not an a, but a negative a. How many times does negative a go into negative ax? X times, good. And how many times does negative a go into positive ab? Negative b times. Oh, perfect. Do these 2 things match? Yeah, so I feel pretty good about that. These match. And so my final answer would be an x minus b times an x minus a. And that's factored. Right? So sometimes we might have to change the order of those things so that we can use the method. All right, last one. Consider this expression. Here's what I want to do. Anytime, guys, that you ever see this, anytime that you ever see a problem where they ask you to find an error, you always, always, always want to just do the problem right. Don't analyze somebody else's mistake, okay? You're going to take the problem, you're going to ignore what was done, and you're going to do it the way that you think it should be done. And then you're going to compare afterwards. So go ahead and do it right. Right? Wouldn't that be our sort of process here? I got 2x squared times x plus 5. I got 7 times x plus 3. And what do we notice? There is no common factor, right? So what did this person do? They took 2x squared plus 7. Was that the common factor? No, that was the stuff that was left over if you took these two things and said that they were, right? 3 times x plus 7? Yeah. But what's 3 times x? If you put 3 times x plus 7, what's 3 times x? 3x. Not. Right? You know what I'm saying? Yeah. All right, I want you to try one more. I just want to make sure we got this. I want you to try the one that was on your 3-point quiz.